The inverse of any graph is a reflection across line y is x. This is the line. So whenever we sketch the inverse of any graph, we're going to be reflecting it across this line. This line will be acting as a mirror to reflect the original graph across. So to sketch an inverse, we follow these steps. Step 1, reflect the original graph across line y is x. Step 2, switch x and y coordinates of each point. Let's start easy with our first example. The inverse of a linear function. This is our linear function, the orange graph. The x-intercept, let's make it -2 is to 0. The y-intercept, let's make it 0 is to 3. So we are gonna reflect this graph across line y is x to get the inverse. Let's see the line here cutting through the origin. So this is our line y is x. We take this orange graph and reflect it across line y is x. That's what we get. Let's give it the same color since it's a reflection, but the name is gonna change. It's no longer g, we are calling it g to the power -1. What else? The coordinates will be switching. 0, 3 will become 3 is to 0. -2, 0 will become 0 is to -2. Ladies and gents, this is the inverse of the original graph across line y is x. And checkmate. Next customer, please. Here we have a line, the purple line, which is cutting through the y-axis at 4. Therefore, we call it line y is 4. Let's draw the inverse of this graph. Step 1, we reflect it across line y is x, but you'll realize that this one is going to be straightforward in the sense that if y is 4, the inverse must be x is 4, because the inverse is like the reverse, switching x and y. Here we have y is 4, the inverse must be x is 4. Here it is. Okay, let's make it purple again. So the inverse will cut the x-axis at x is 4. And we call it line x is 4. So the inverse of y is 4 will be x is 4. Not forgetting our reflection line here through the origin. Line y is x. So line x is 4 is reflecting line y is 4 across line y is x. That's the inverse. And checkmate. Now this next one, the blue graph here, is a popular one. If you check past exam papers, you will see it trending a lot. So this is an exponential function. We are going to draw its inverse, which is going to be a log function. Sometimes you are given a log function, and then when you reflect it, its inverse is an exponential function. Let's analyze. This exponential function, the blue graph, it's cutting the y-axis at 0 is to 1. That's the y-intercept. So we are going to switch this y-intercept to become x-intercept, which is what? 1 is to 0. Remember, 0, 1 will become 1, 0. 1, 0 will be somewhere here. 1 is to 0. But to do it right, the inverse is supposed to reflect across this line, which we call line y is x. But other things are these, guys. You need to check how close to the axis this graph is, the blue graph. Remember this. This is the negative x-axis. This side is the positive x-axis. Here we have a positive y-axis. Below 0 we have a negative y-axis. Check this out. The original graph is too close to the negative x-axis. You see, too close here to the negative x-axis. So the inverse must do the reverse of that. If the original graph is too close to the negative x-axis, the inverse must be too close to the negative y-axis. You are switching x-axis with what? Y-axis. Original too close to negative x-axis. The inverse must be too close to negative y-axis. Somewhere here. But check out the original. While the original is too close to the negative x-axis, what's it doing? It is curving towards the y-intercept. So the inverse will be too close to the negative y-axis, but curving towards the x-intercept. Let's do it like this. Nazo. The original is called f. The inverse will be f to the power negative 1. The reflection line is line y is x. The y-intercept is the x-intercept. Y is becoming x. This is the first example of sketching the inverse of an exponential function. And checkmate. Another one. Pause the video, try to sketch this decreasing exponential function. The graph is called h. We are going to sketch the inverse of h, and we're going to make sure it's reflecting across line y is x. Let's analyze the original graph. Firstly, remember, this side is a positive x-axis. That side is a negative x-axis. Up here, a positive y-axis, and under 0 here, a negative y-axis. So let's check what the green graph is doing. It is too close to a positive x-axis. Too close. So the inverse must be too close to a positive y-axis. Somewhere here. Now you will notice that this original graph, the green one, while it's too close to the positive x-axis, it is curving towards the y-intercept. Now remember, when we sketch the inverse, we switch the coordinates. 0 is to 1 will become 1 is to 0, somewhere here. 1 is to 0. So if the original graph is too close to the positive x-axis and at the same time curving towards the y-intercept, the inverse will be too close to the positive y-axis and curve towards the x-intercept. Let's do it. Okay. So this is the inverse. It's cutting the x-axis at 1 is to 0. The original cutting the y-axis at 0 is to 1. The original is called h. The inverse is called h to the power negative 1. They are reflecting each other across line y is x. Cutting through here. So now remember, when you draw the inverse of an exponential function, analyze the original graph. In this case, the original is too close to the positive x-axis. The inverse will be too close to the positive y-axis. And checkmate. This is another popular one, a parabola. So we are going to sketch its inverse. Okay guys, you're going to be happy to know that this one is straightforward, because what you do, firstly you check that this graph is pointing towards the positive y-axis. Its inverse must point towards the positive x-axis. Let's do it. The inverse will point towards the positive x-axis, like this. Not forgetting the reflection line y is x right through the origin and through the graphs like this. So we can still sketch another parabola. Remember, this blue one we just sketched here is concave up. It's a happy face. What about a sad face? Let's see. Let's say we have a graph like this. This is our y-axis, our x-axis. This is the concave down graph now. A sad face. Still turning at 0 is to 0. So in this case, when we analyze this, we check the fact that it is pointing towards the negative y-axis. So the inverse will point towards the negative x-axis. So y becomes x. Let's do it. It's going to be something like this. Let's call the original graph f, the inverse f to the power -1. Not forgetting the line y is x through the origin, like this. And up here, the original is f, the inverse, we call it f to the power -1. So this is how we sketch the inverse of a parabola. And checkmate.